Put your hand over your heart right now. You just pointed to the wrong place. Your heart isn't on the left side of your body. It's not even mostly on one side at all. And the reason you believe this, your entire life says something strange about how your own body actually works. Let's start with what's actually happening in there. Your heart sits almost dead center in your chest, right behind your sternum. Not shifted left, not tucked under your left ribs the way you've been pointing your whole life, centered. What is shifted is the orientation of the heart itself. Your heart doesn't sit straight up and down like a simple pump. It's rotated, tilted at an angle. Its pointed bottom tip, the part called the apex, angles down and toward the left side of your chest. That tilted apex is the only part of your heart that actually sits on your left side, and it happens to be the part that beats hardest against your chest wall. When you press your hand against your ribs and feel a thump, you're not feeling your heart. You're feeling the apex, the tip, the single most physically active point of an organ that is otherwise sitting almost perfectly in the middle of you. Here's the part that should genuinely surprise you. Roughly 2/3 of your heart's actual mass sits to the right of your body's center line, not the left. The right atrium, the right ventricle, a significant portion of the right side of the heart occupies more real estate slightly right of center than the parts that occupy the left. You've spent your entire life pointing at a heartbeat and calling it your heart's location. What you were actually pointing at was just the loudest corner of a structure that mostly lives somewhere else. Now here's a question worth sitting with before we go further. If the position of your heart is this fixed, this predictable, the same tilt in nearly every person who has ever lived, then identical twins should always share the exact same internal layout, same organs, same side, mirrored only in the way any two people standing side by side are mirrored. But in extremely rare cases, they don't. Some twins are born as true internal opposites of each other. Hold on to that, we'll come back to it. So why does almost every human being on Earth make the same mistake about where their own heart is? Anatomists have a fairly simple answer, and it comes down to how your brain processes sensation versus reality. Your nervous system is extremely good at localizing sharp, sudden, or rhythmic sensations to a specific point on your skin. A heartbeat you can feel is a rhythmic mechanical thump against your ribcage. Your brain locates it exactly where the physical contact is strongest, at the apex. Your brain isn't mapping the internal geometry of your heart. It's mapping where the sensation hits your skin. Because that sensation happens to hit on your left side, your brain built an entire lifelong assumption around a single contact point, instead of the organ's actual shape. This isn't unique to the heart. Humans consistently misjudge the location of internal organs based on where they can feel activity rather than where the organ actually sits. Your stomach isn't where most people think either. That's a different video. Now here's where this gets stranger. Because for a small number of people, none of what I just described is even close to true. In 1788, and then repeatedly over the following 2 centuries, physicians performing examinations occasionally encountered something that broke every assumption in the textbook. A heart that wasn't just centered or slightly rotated, but a full mirror image of a typical one, tilted to the right instead of the left, as if someone had flipped the entire chest cavity like a photograph. This condition is called dextrocardia. Roughly 1 in every 12,000 people are born with it. In the most extreme version, called situs inversus totalis, it isn't just the heart. The liver, the spleen, the stomach, nearly every asymmetrical organ in the torso is a complete mirror image of where it sits in a typical body. Left becomes right. Right becomes left. Every internal landmark that surgeons and anatomists rely on is inverted. And here's what makes this genuinely unsettling if you sit with it for more than a few seconds. People with complete situs inversus are, in almost every functional sense, completely healthy. Their organs work. Their hearts pump normally. Many people with this condition live their entire lives without ever finding out, because nothing about how they feel gives it away. It's only discovered by accident. Usually during an unrelated scan or surgery, when a doctor opens up what they expect to find on one side and finds it perfectly symmetrically on the other. There's a well-documented case of a man who went in for a routine appendix removal in his 50s. The surgical team couldn't find his appendix on the right side, where it's supposed to be. It took a scan to reveal that his entire internal anatomy was mirrored. He had lived over 5 decades with a heart tilted to the right, a liver on the wrong side, and had never once had a reason to suspect it. Scientists still don't fully understand why this happens in every case, but part of the answer starts at a specific stage of very early embryonic development. A group of tiny hair-like structures called cilia beat in a coordinated rotating pattern at a structure called the embryonic node. That rotating motion pushes molecular signals consistently toward one side of the developing embryo. Those signals are what tell the body where to start placing asymmetrical organs. Left gets one set of instructions, right gets another. In typical development, this process is remarkably consistent. In dextrocardia, something disrupts the direction of that signal, and the body builds its internal architecture as a mirror image instead of a copy. Now back to the twins, because this is where the mechanism gets even stranger. That cilia-driven signal doesn't happen gradually over weeks. It happens in a narrow developmental window, and in a small number of documented cases involving identical twins, something remarkable occurs. When a single fertilized embryo splits into two separate twins after this left-right signal has already started, but before it's fully locked in, the split itself can interfere with which twin receives which version of the signal. In the rarest of these cases, one twin develops with a completely typical internal layout, and the other develops as a full mirror image. Situs inversus in one twin, a standard layout in the other, same DNA, same womb, same starting moment, opposite internal maps. Researchers who study this call it mirror image twinning, and it remains one of the few situations where two genetically identical people can be told apart not by their faces, but by opening them up and finding their hearts, their livers, their entire internal architecture, arranged as reflections of each other rather than copies. So think about what that means for a moment. The location of your own heart, something you felt beating under your hand since before you could talk, something you'd swear you know with absolute certainty, is actually the product of a molecular coin flip that happened when you were a microscopic cluster of cells, weeks before you had anything resembling a heartbeat at all. Most of us landed on the common outcome. Heart-centered, apex-tilted left, the same internal blueprint shared by the overwhelming majority of humans who have ever lived. But every single one of us is carrying around an internal map we've never actually seen, built by a process we have no memory of and no control over. That could just as easily have gone the other way. The next time you put your hand on your chest and feel that thump, you're not really finding your heart. You're finding the one tilted corner of it loud enough to prove it's there. The rest of it, the majority of it, has been sitting quietly in the middle of you this entire time, exactly where you never thought to look.